Hey there, 3Xers. So we've gotten into what we call complex inequalities, and we've seen that we're going to deal with different types of lines intersecting. I'm only going to make two videos here with inverses and linear functions and square roots and linear functions, which will be in a different video. So as you can see, we're faced with this problem here. I have a linear function, and I want to see when it's less than an inverse function. So what we've been doing is putting this in y1, and this is y2, and I just made a quick graph of that right here, that we can see our linear function is the green line, and then the inverse is the blue. So let's label that even with our little, that's blue, that's the linear green. Now from here, we can visually see where that line is underneath, but we really need to know where these intersection points are, because those are going to be the breaking points of when it's above or below. So again, I've gone with just the work here quick. I know it's not going to be handwritten, but I'll walk you through it. That we need to see where these two equations are equal to each other, and these two expressions are equal to each other to find the intersections. So the first thing you want to do actually is multiply both sides by w. That gets rid of the division over here, and eventually you'll get a quadratic on this side. So I multiply both sides by w, I get w squared minus w equals 20. Make sure you distribute that. From here, it's set up that I have my a and my b, but I need my c on one side. Don't factor a w or anything like that. Get your 20 to the other side so you have the possibility to either use a quadratic formula or factor it. Now if you want to try this, you can try and factor it or stop the video right now, see if you can get through this problem. And as you can see, we're looking for the multiples of negative 20 that add to negative 1. So hopefully you're thinking negative 5 and a positive 4. And I believe they factored it to that. W minus 5 times W plus 4 equals 0. From here, I can find my two intersection values. I want to set each parenthesis equal to 0. So W equals 5, W equals negative 4. So that gives us our intersection. So I know from this picture now that this one is a negative 4. And here's my 5. But from there, I can't just shade in between a negative 4 and a 5. Now those will go on my number line here. There's my negative 4, and here's my 5. But visually, sometimes this can be tough to see where this is actually above or below a certain value. So I'm looking to see when the green line is below the blue. Now remember, for certain x values, we're just looking vertically. And I notice this x value right here, the green line is below the blue, so it should be shaded. That one works, this one works, so pretty much all of this graph is underneath from here up into this intersection. And then the blue line's underneath. Now as I'm going left to right, I notice, oh, well, right after 0, this portion of the green line is underneath the blue. So I'm kind of shading where the graph is underneath, looking at those vertical x values, and then it stops at 5, and now the green's above. So that's where we're going to have to shade. So I think it's easy here is that we're going to shade all the way to negative 4, and we're going to have an open dot because it's just a less than. But it stops for a while, and then it has this value here. Now what's special about inverse is decreasing at a decreasing rate, and then it switches right after 0, and now I'm still decreasing at a decreasing rate. I'm sorry, this is decreasing and increasing. But anyway, after that, it shoots up into the positive infinity. So it switches sides of the line without there being an intersection. So since there's no value for the inverse at 0, there has to be an open dot at 0. But everything in between does work. So I have up until 5. Just to practice, let's have the symbols for this. So this would be x is less than negative 4, and I'll move that over. Now we do have a stoppage in the shading, so I have or. X is going to be between 0 and 5, so we go less than x less than 5. So that's the shading of this, or sorry, the symbols for that. And let's practice. We just learned that recently, the interval notation for this. So notice that we're coming from negative infinity. I'm going to have to write in that negative infinity now that I think of it. So I'll have the parenthesis, I'll leave the space for the negative infinity, all the way up to negative 4. And I've stopped shading, but it's an open dot, so I get a parenthesis. I'm going to have a union, and then I'm going to have from 0 to 5. Again, all parentheses, so I'll type in or draw in this negative infinity. I don't know the quick. I'll just go 00 here. A little tough with that. So there's my negative infinity to -4, and then from 0 to 5. So we have it in all three ways that we're going to have symbols, number line, interval notation for this shading. Some little tricks. Inverses are always going to be shaded one way to infinity, and then there's going to be a little section where it's shaded in between. That's just how these kind of work out with the switching of the positive negatives. Now if I were to switch this sign, I would be above 5 or in between 0 and -4. So obviously we'll get a lot of practice with this in the homework, but this is just kind of step by step that find your graph first, see where it is, find the intersections, and then be careful. If you need to test some points in the inequality, do that. Put in a 1. 1 minus 1 is 0. 20 divided by 1 is 20. 0 is less than 20. Yeah, it's got to be shaded. All right. Hopefully this helps. Have a good night, good day, whatever time you're watching this, and I'll see you in class.